This video is going to be a quick breakdown. This procedural setup. I first made this in Houdini with two methods. The first one is a simulation method where I just created the line between each of the points and then used the vellum simulation to simulate the drop of the wires. And then the second method is using a curve node that allows me to shape this kind of shape. And once I did the second method that does not involve simulation, I tried to recreate it in Blender geometry nodes as well. Don't mind the group inputs here, as well as these this combined transform with transform gizmos. They just allow to create this kind of gizmos so you can interact with the geometry directly in the viewport. I will be tackling just the usual nodes. So we can just hide this. Sometimes there's a bug where it doesn't hide when you unclick this, but just disconnected. Normally it should work. We start by creating these two grids. So we have two grid nodes, and then each one is transformed accordingly so that they have this exact shape, one following the other. This here is just to give them both some thickness, and then join them with this setup. This setup is the one that creates the points on the, it's the one that creates the little boxes at the center of each face. We look at this. This is our geometry. The first thing we want to do is extract the center of each face, and in order to do that, we're going to use a node called dual mesh. So this is our input, right? We'll notice that once we input it into the dual mesh node, we get this. I try to draw. You'll see that these were the old faces. Okay, and the dual mesh. So this is the old faces, and then when you plug it into the dual mesh, you can see that with the new faces, each vertex of the dual mesh is actually the center of the previous face. That's exactly what we need. After that, all that is left is here. If we look at these instances, you can just instance the points, the cubes exactly at the vertices of the dual mesh, and then at the end they will be placed at the center of each of the previous face. After we join them, we get this. This is exactly what we want. This node here does exactly the same, but instead of scattering cubes, it just scatters a bunch of points at the center of each face. After that, we use the set ID node. This allows us to give each point an ID. So if I plug the ID into here, then you attribute text, you'll see that each point has an ID starting with 0 from the bottom here, and then 1, 2, 3, until we have the total number of points. So the idea is that we're going to have an ordered ID on the first cube, but on the second cube, we will have a shuffled or scrambled IDs, so that the points connect randomly. 2 points that have the same ID will connect randomly. And so for the first plate, we don't need to randomize the ID, we just keep it as it is, and then we're going to do the shuffle in for the second. So if we look at the second plate, we did exactly the same thing as before. We created the centers with the dual mesh and then scattered the points. But now here is the difference. We're going to use the sort elements node. This allows us to create to shuffle the IDs. First of all, I use this domain size that gives me the number of points. If you take a look at this, you'll see that it outputs exactly the number of points. You need to set the domain to be point cloud, otherwise it's not going to work if we set it to mesh. So set it to point cloud, and then we will use a random value node, which the maximum possible number will be the domain size, which is the maximum the maximum ID we have on this plate. And then we will plug it into the sort weights. And the sort elements node here is going to resort the indices. So this one does not act on IDs, it acts on indices. It will give each point a random index. No index will be repeated twice. We'll just give them scramble the indices around the points randomly. That's why we use the random value here in the sort weight. But then since this is indices, we need to to plug the indices into the ID. So we want the ID actually to become the new scrambled indices. That's why here we use again the same node set ID. But this time we plug the new index into it. So we tell it that the new ID is going to be the index. And if we join this, and you might ask, why did I use ID instead of index? It's because you can't have the same index on 2 different points. That's why we use ID. Whereas with ID, you can have 2 different points with the same index. That's why I use ID. So as you can see, when I plug here index, when we join the 2 geometries, you can see that the indices change. So they keep increasing. You can see here this is 237, whereas we only have 135 points. So the indices keep increasing. But when we look at ID, you can see that they are repeating. So this in this plate we have IDs from 0 to 135, and in this place we also have from 0 to 135, but they are shuffled. Then to connect them is very easy. We just use a points. Let me disable this. We just use points to curves, and here you can tell it by which type of group ID will it connect the curves. So when we plug the ID, it means that for every 2 points or multiple points that have the same ID, they need to be connected. And so we get this type of a pattern here. After that, we resample it. Since we'll be displacing the curve, we resample it. And this is where the shaping of the curve occurs. So we use a set position, of course. Then we do it using a spline parameter. So if we take a look at the factor, you can see that it's a value going from 0 to 1 at the tip. We then plug it into a color ramp because I don't want to move the edges. So that's why you see it's black here, black at the edges, and then white in the center. This is where I want the displacement to have the most effect. So if we take a look at this, you can see the center is the white area. And then we use a float curve to tell it to reshape the curve. We take a look at here, so you can see that you can click on this and it allows you to adjust the min and max for the x and y values. You probably need to go down a little more, that's why I adjusted the minimum y to -3. And then I just multiplied this shape with the color ramp we created earlier. And I also added a little bit of noise to this ramp to not have it be perfectly like a curve and have a little bit of displacement from the noise. And then I just multiply this to control the amplitude of the noise. And then if we look at the set position, you can see that we have this kind of shape. So as I said, we can play with the multiplication of the noise. We can play with the size, the shape. See, the lower you go, the more you can define how gravity impacts the wires. And then we have this to, as I said, control how the edges are impacted by the noise. So if we go down, you'll see that this keeps the original shape and only this spot is impacted where there is white. Then finally, we use this node that was introduced in Blender 5.0, I think, called curve to. Sorry, let me disable value. Called curve to 2. So it just acts as this node here, curve to mesh. But it just provides an already created profile curve for you, which is going to be a tube with the different parameters exposed, like the resolution of the tube, to create UVs on the tube and whatnot. It's quite useful. We take this down to 25 minutes, maybe, and then we joined this with the earlier shapes we created, and then that's it. Now we create this procedural setup. When you move, you can move this as I did earlier, and it will update accordingly to what you created with no issues. You can always go further and develop some of the nodes. I think the fact that I created this in Houdini and then tried it again on Blender made it quite a fun exercise to see the differences between the two softwares. And I think that's a very good way to learn geometry nodes. That's it. Thanks for watching.